Good morning, good evening, good afternoon, whatever time it is, wherever you are, and welcome to the OpenStack Unlocked podcast. This is our second episode of 2016. We are here with Heather Kirksey, the director of the OPNFV project. I am Nicholas Chase, and I am here with my esteemed co-host, John Jainschigg. Hello to both of you.
I'm John, and the dog is Johnny.
Yes, this is Johnny. That's he hasn't seen me in 3 days because I've been down with a back injury, so just ignore him. He has his own opinions, but we don't let him express them on the podcast. So, Heather, thank you so much for joining us.
You are welcome.
Yes. So I understand you've just come back from a trip to Asia.
Yes, I landed yesterday from Beijing. I was participating in a China Mobile open source workshop.
Oh my goodness, that is a long trip, and that, by the way, is why we have Heather on audio, because we are merciful. So anyway, so Heather, tell us a little bit about what you learned over at China Mobile.
It was a great meeting. Just kind of talking to, China Mobile is on our board. Dan Kui is actually one of our board officers. So they've been really engaged with us from the beginning, but it was good to sort of hear their perspective and, sort of get an idea of kind of how open source is growing in that market, and how they're embracing it and getting the word out to those folks.
Excellent. So what I should probably do is kind of do a level set to start with. I apologize to everyone. As you can tell, I am not at my best today. Let's talk a little bit about what NFV is and what OPNFV is. OPNFV, the acronym for Open Platform for Networks Virtualization Project, right? Network Functions Virtualization. Let's start that again. OPNFV is the Open Platform for Network Functions Virtualization Project. Is that right, Heather?
That is correct. It does not fall trippingly from the tongue.
No, try saying that 10 times fast. Yeah, so what does that mean exactly?
Yeah. So, for folks who aren't familiar with NFV, that's a network transformation that's going on. It is moving away from the proprietary, custom-built, vertically integrated, sometimes single function, bespoke elements in the network, and moving towards basically moving those into software as elastic cloud applications. So in a telco world, those could be things like a deep packet inspection appliance, or possibly an edge router. A lot of folks are looking to virtualize customer premises equipment so that those can be better managed. The gateways and things like that providers put in your home. So it's sort of the continued evolution of software eating the world, and now it's coming to networking after having come to compute and storage.
So this is basically. I'm sorry. Go ahead.
Oh no, go ahead.
I was going to say, so this is basically a very specific function of software-defined networking in a lot of ways.
Software-defined networking is an important piece in NFV, but this is in some ways broader because it's really sort of all of the different types of elements that are out there in the network, moving those to software. Gotcha. So SDN is one of our sort of key enabling technologies. But sort of SDN is about the separation of the control plane and data plane, which is a very useful sort of concept as you're virtualizing. And then NFV is kind of specifically looking at virtualizing all of the just different things that people have in their network currently.
Gotcha. Okay. And so now each of these pieces are are VNFs, correct?
Yeah, so VNF is the term that's actually used for the specific application itself. So if you look at what's considered sort of the NFV architecture that came out of a group called the ETSI NFV ISG, which was the group, the sort of the initial group that really started looking at this problem.
OMG. I feel like I'm in a Robin Williams moment for this.
The thing about the telecom industry is that it really, 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 really likes acronyms. And so the telecom acronym soup is definitely one of those interesting things. And so, yes, you will see a lot of that sort of stuff in our industry. But the reference architecture for NFV that this group came up with basically has at the infrastructure layer what they call NFVI or NFV infrastructure, as well as the virtual infrastructure manager, which is where OPNFV has focused to date. And then above that, you have the actual sort of VNFs, which are the specific applications. So you could think about it as sort of the platform, and then you might have an application that, say, mimics deep packet inspection. Well, not mimics it. It implements deep packet inspection capabilities, for example. And so all of these are virtualized applications that can then run on the platform.
So these are virtualized network functions.
Yep.
So these were all, so a lot of these then originally had been implemented as actual specific hardware rather than as software.
Right.
So I could see where that would be difficult to kind of scale and be very flexible then.
Yeah. The flexibility part is definitely a big issue. As the telecom service providers are looking to be more agile, looking to roll out services more quickly, one of the big limiting elements is just how hard it is to do because of all of the different elements that you have to go provision, and they each have their own interfaces, and getting it all sort of working together for a service is fairly complicated. So that's the move into software.
Gotcha. I had a question there. It's completely gone. Completely fallen out of my head. John, how about you?
So the evolution from shall we say old school telecom hardware went through an intermediate stage, didn't it? Where what we were beginning to see was something on the order of white box devices that were running software in order to produce their designated effects as DPI or load balancing or firewall or whatever they were. And I guess the producers of today's VNFs and tomorrow's VNFs are really leveraging that sort of second stage of evolution more than they are the historic, implementation of stuff in hardware and firmware.
Yeah, definitely. And I mean, and that's just sort of increasing. So from a CapEx perspective, the move to white boxes obviously has a big impact. One of the things that's important as this is moving for telecom applications is really throughput and performance. If you're moving to a white box environment and looking to implement the functionality of, say, an edge router where it processes lots and lots and lots of packets per second, that's not necessarily sort of the throughput for a traditional application. So there's a lot of work that goes on that's going on around those aspects too, around basically data plane acceleration to ensure that we get good performance. So while being able to reap the benefits of moving to a white box environment.
Gotcha.
So that's an enhancement to the platform layer, to the network interface part of the platform layer, and then OPNFV functions at the virtual infrastructure manager layer.
That's what our focus has been to date, but I would expect to see us begin to focus on what's called MANO, which is around the actual management of that infrastructure. So we have the virtual infrastructure manager, but I expect us to go up into orchestration and management as well in the future. I was going to say, actually, I realized we never kind of got to what OPNFV is. We were talking about NFV. Just a quick overview of the project. So, kind of going back to, I mentioned the ETSI NFV ISG group, and that's where a lot of the original telecom operators got together, sort of came up with the concept, created a lot of the initial architecture. And then, the traditional way of working in the telecom world is that there are standards organizations like ETSI that will generally produce specifications, and then vendors go off and implement them. And then there will be various events around interoperability to show that vendors' products can work together. And but all the implementation is kind of done siloed within a vendor's walls. And obviously the telecom operators want to move very quickly to this new architecture, and so decided that we needed an open source project to allow the industry to kind of innovate together and collaborate together. And so they started up OPNFV. I think it's about 15 months ago now.
So what does this all have to do with OpenStack?
So
there is actually a tie-in.
Yes. So OpenStack is a key part of our platform. So as I mentioned, this is really about moving all these network functions into cloud applications. And so the virtualization platform that we've gone with is OpenStack. And so it fulfills a very important piece of the NFVI and Vim layer of the stack.
Okay, so basically, OpenStack is the part that enables you to sort of requisition all these pieces and schedule them and put them where they need to be.
Mm-hmm. Yes. So as a project, we're a little bit interesting in that the belief by a lot of our founders was that a lot of the pieces were out there for an NFV platform, but they needed to be brought together. So we do a lot of systems integration and testing work. Rather, it's not our goal to fork any projects. It's not our goal to reinvent the wheel or do something when it's already out there. So in Arno, which was our first release last year, it was an integrated build of OpenStack, Open Daylight as an SDN controller, KVM as an open source hypervisor, and Open vSwitch and Linux.
So really, if I'm understanding correctly, and from the literature, what I'm seeing is that the OPNFV project, what you do is not so much produce a piece of software, you produce a reference architecture that explains how all of these pieces fit together and makes sure that nothing's missing, correct?
Correct. So there are kind of three pillars to what we do. One piece is around that integration work. So, identifying what pieces are out there and then making sure that they do integrate, finding any issues, and then being able to deploy in an automated fashion that, composed platform. Then our second pillar is really around testing, and some of that's functional component testing, also at a system level validation, as well as a lot of performance testing, which is really cool, because that's not something necessarily a lot of open source projects that are focused more on code production don't necessarily spend, or have the necessarily have the sort of the drive to do a lot of performance testing. So we're doing performance testing of pieces of the platform as well as the overall platform. And then our third piece is around requirements and gap analysis. For example, using OpenStack as a good example, the carriers were looking at it, and for the sort of fault management that they needed to do, OpenStack in the Juno timeframe and Kilo, it took too long to sort of detect faults. so that we could do failover things from a telco perspective. So we had a project called Doctor that did a gap analysis and submitted some blueprints into OpenStack, and many of those blueprints have actually been incorporated into the Liberty release. So, and then, then we will take down Liberty and integrate it with sort of new versions of the other components. So it's this sort of virtuous cycle of looking at sort of everything through the lens of NFV, and, taking changes upstream, then integrating those, doing more testing to see what additional changes we might want to see.
Excellent. And now, so your next release called Brahmaputra is coming out sometime soon, correct?
Yes.
So what should we expect to see in Brahmaputra?
So lots more choice in various aspects. So we have more installers participating. We're going from 2 to 4 different installers who will be able to build the platform. Additional SDN controllers will be enabled. So in our first release, we went with Open Daylight. In this release, we'll be adding ONOS and Open Contrail. Obviously, newer versions of various components. So we were on Juno in our Arno release, and we'll be taking in Liberty. And this one, a lot of work around testing. So we went from 1 testing project in our first release to 5 testing projects. In this one, we added in the system level validation tests, as well as 3 different performance oriented testing projects. So we've done a lot of work around sort of expanding that aspect. And all of these things are, integrated in with our CI/CD tool chain. So, everything's automated. Labs can become our Jenkins slaves and run all of these suites of tests internally on their own infrastructure. We've had a lot of work being done on our community test lab program, which is called Pharos. And we actually are having Pharos labs participate in the release process itself. So in our first release Arno, people did dev work there, but all the release work was done in the OPNFV lab that's hosted by the Linux Foundation. And in this release, actually, we are using community bare metal resources to participate in the release as well. So that's really exciting. People are not just bringing folks to the table, they're actually bringing, hard resources, and they're participating in the release. So that's pretty cool.
Tell us a little bit about these labs, if you don't mind.
Yes. Yeah, so it's a really cool project. So the name of the project is Pharos, and it is our federated community test lab program. And so we actually, in this release, also have tightened down sort of the governance and what's required of the labs in terms of being available to access. To participate in the release, they actually are providing bare metal access, and it's nice because we get a bunch of different hardware to test on, so we can validate that the release isn't hardware dependencies haven't snuck in somehow behind our backs.
Bad hardware dependencies.
I know, right? You try to keep them down, but they always try to sneak in. And also from a hardware architecture perspective, we actually had our first ARM lab get stood up a few months ago, and so we actually can test across different hardware architectures as well. So it's a really cool program because it enables us to do a lot more testing. Our releases we test on bare metal, and so getting access to that to those resources there's no way that we as a nonprofit could afford the amount of servers that we would need to do everything that we need to do on bare metal. So having these folks participate in the program it's really key to what we're doing. And I think in this release, labs at Intel, Ericsson, and Huawei are actually being part of the release. And then I believe Dell and ZTE and Orange have been bringing lab resources that some development work is being done on. And I hope I am jet lagged, so if I missed you, it was not intentional.
We promise we'll add it to the show notes if you missed anybody.
Okay.
How's that? Okay. Yeah. So now this week, or this past week, I should say, the OpenStack Foundation released a white paper about NFV that talks about OPNFV as well, but it talks about the relationship between NFV and OpenStack, and it concentrates very heavily on carriers, but it's not just carriers.
Right.
I mean, I think I've heard you say that, carriers are the ones who feel the pain points most distinctly at the moment.
Yes. I mean, they're sort of the ones trying to roll out new services with all of these different elements in their network. So they are definitely experiencing, I think, the most pain. But at our OPNFV summit last year, we actually had a panel that had sort of a wide variety of companies, and I think fin services industry. So we had someone from a fin services infrastructure as a service provider, who they provide basically services to the high-speed traders and hedge funds. And NFV is something that they're looking at. It's important to them. So definitely, and there are enterprise use cases, and I think enterprises will also be moving there, sort of commensurate with how much pain networking is for them. Depending on sort of exactly what sector they're in. Obviously networking is very important for someone who's providing services to high-speed traders. Right. Networking issues can cost millions of dollars if there are problems or performance issues, et cetera. So I think to the extent that networking is either core or central to someone's business, that they'll move there first. But I could certainly see there are use cases around virtualized business, CPE, and like branch connection and things like that NFV could certainly help with. That you could see larger enterprises definitely benefiting from.
Right, and it's one thing that we've discovered here is it's not just a matter of network reliability or performance or anything like that. I was having big trouble in my position. I write about a lot of stuff and I explain why it matters, and I was really having a lot of trouble explaining why NFV matters to the enterprise, because every example that I was given was, we have these telcos and they have these, edge router, blah, blah, blah. The exact explanation you gave, which is great if you're only talking about telcos. But about, John, when did we do the Palo Alto release? What, about 2 weeks ago?
A little longer, but yeah.
Yeah. Sometime in the past few weeks, Palo Alto Networks released the VM series virtual firewall, which is a VNF that gives very granular control over traffic, east-west traffic within an OpenStack cloud. Now, I'm not trying to, advertise their product, but I'm kind of using it as an example. This is something that enterprises and any enterprise that has complex requirements can get some usage out of, and they don't have to be a telco and they don't have to have these huge performance issues. Basically what I'm trying to say is network functions virtualization is really the process of gaining this really significant control and agility over your network.
Yes.
Would you say that's correct?
Yeah, I would definitely say that's correct.
Yeah. So,
and one would think that it would be increasingly important for enterprises, as the heterogeneity of applications that are running on scaled out cloud infrastructure increases. When you look at OpenStack as it comes out of the box, basically you have security groups.
That's pretty much it.
they're sure fun. And you have, VXLAN if you want to get down there and, and build little segregated networks for yourself. But, the next jump is to SDN. And after that, if you want more, more power and more ability to drive things and scale things from scripts, and move things through, seamlessly through CI/CD, for example. I mean, imagine doing CI/CD on complex networked applications without, without the ability to build, to script service insertion and systematize it to the extent that you can move from dev to test to production. The whole, the whole agility is lost from development.
That's true. So all you Neutron haters, always getting on the Neutron haters. All right. So, all right. So I think we've pretty much covered it. Heather, was there anything else that you think is important for our audience to know?
Yep. Networking is obviously increasingly important, for a number of reasons. We would love to have more participants, basically. I always end every time I'm talking with sort of a call to participate and get involved. It's an interesting problem. It's a hard problem, and it's an impactful problem. Redesigning the global, I'm going to focus on telecom just momentarily, but redesigning the global telecom networks to make them more agile and more software oriented is pretty cool and really exciting, and really, does have an impact on, our connected society. So, I just encourage folks to get involved. It's also extraordinary seeing sectors that have not necessarily been open source friendly in the past embrace open source. So it's definitely it's a fun organization, and it's really fun seeing a lot of companies that have been around for a long time reinventing themselves.
Excellent. John?
No, but I have one recommendation. If you are stumped by the acronyms that you confront in dealing with telecommunications, Newton's Telecom Dictionary, which I believe is still in print after 18 some odd years, is a very good, if heavy, reference and can be used as a doorstop in between consults and lookups.
John, you came from telco, didn't you?
I did indeed, yes.
I forgot about that till just that moment. All right, excellent. Well, I would encourage you all to come visit us at podcast@openstackunlocked.com. And I want to thank everyone for joining us here. John, thank you for, as always, for not just being my co-host, but also our technical brains and behind this thing. And Heather Kirksey, again, Director, OPNFV Project, thank you so much for joining us. I know that you're just back and your jet lag is horrendous. So thank you for joining us on this morning for you. For everyone else, thank you so much for joining us, and we will be back with another scintillating and hopefully less crazed episode of the OpenStack Unlocked podcast. Thank you so much.
Good.
Thanks, everyone.
Bye.